Hello and welcome to this tutorial. This chapter is the closure of this project. In the previous chapters, we have created this rim and its levels of detail. Today, we are going to texture these models through bake-to-texture process. In the background, I am preparing the scene for the bake-to-texture process by adding an Omni light and adjusting its attributes. All these steps are fully uncovered in Chapter 1. These preparations are important before baking the required maps. A proper distribution of the light over the geometry will result in better projection and minimize further image editing after the bake. From the L0 layer, select the rim and its components. The most important step in the preparations is to wrap these parts. To ease the wrapping process, I am going to turn to poly modifier from all of these parts. Later, we can add it before exporting this project. For more information about how to prepare your project for exportation, check the link in the description. To be assured that all the selected objects are at the object level, add Edit Poly modifier to the selection, then collapse the stack. To start the wrapping process, add Unwrap UVW modifier to the selection. Let's take a look at the current UV map. This is the automatically generated map by 3ds Max that was formulated during the modeling. Definitely, we need to clean this mess. Inside the editor, press Ctrl A to select all the UV clusters. Project the selection over a planar projection on the x-axis. Notice that I left the normalize map enabled, however, I strongly recommend you to disable it on your editing, unless you know exactly what you are doing. For the best mapping of the rim, normally, you want to keep the side UV clusters as they are, and scale, then move all the other clusters. Be notified, this is not the final UV map. Currently, we are creating a template UV map that will drive the projection modifier. Through these clusters, inside the checker box, we specify how the projection, or the bake, will be. The best optimization of the texture's 2D space is by utilizing its scale to the limit. Though, we can use this new UV map to bake the required maps. The current UV map is not the most optimized map for the texturing process. When baking textures, we will be limited by the map scale or dimensions. Also, we will be limited by the amount of pixels that will represent those textures. In short sentence, if we can only use a portion of this UV map to bake the textures, then unwrap the others on that portion by overlapping similar UV clusters. That will be the defined meaning of optimization. Not only we will utilize the maximum scale of the map, but also we will have high-resolution maps without the need to increase the map dimensions. However, the only disadvantage of this technique is that sometimes it demands further image editing after the bake. Once we go further in this tutorial, you will have a better understanding of this technique. We can break the side UVs into 5 identical clusters. Theoretically, if the modeling and the wrapping process were done correctly, we should have a perfect overlapped clusters. If that was not the case, disable Normalize Map in the modifier settings. Then redo the wrapping process. Any UV clusters outside the checker box will not be used by the projection modifier. Our work here is now complete. Render a template UV for the 2D editing. Collapse the UVW modifier. Go back to the high resolution layer. Select both the rim and the bolts in order to change their color in a proper way. Open the material editor. Create a new standard material. I am going to leave the ambient color at 150. Change the specular color to 173. Notice I left the specular level at 0. I should attach the bolts to the rim in the L0 layer to form one single object before adding projection modifier. However, I decided to project the bolts later when texturing the L1 layer. After adding the projection modifier from the pick list, select the high resolution rim. Then push the cage by 2 mm. You can add the projection modifier to multiple objects. In such case, the projection modifier will bake maps for each object separately. Hit 0 on your keyboard to open Render to Texture utility. Under Projection Mapping, enable Projection. Press the Pick button to pick the high-resolution model. Ignore that if you already picked the high-resolution model from the projection modifier. From Options, disable Ray Mischeck. Disable Sub-Object Levels Projection. The default UV map channel that will be used is 1, leave it as it is. Unless you want to bake different channel UV map. For this project, we will bake complete, normal, and specular maps. It's always a good idea to bake the maps in larger dimensions, more than those you intend to use. It's also a good idea to bake the alpha channel with maps for the purpose of image editing. I am using the TGA file format to pack the alpha channel. You can change the background color of the projected elements to whatever color you want. However, I do recommend to pick a color that will match the projected element color and the projected map. The grayscale is the best match for diffuse and complete maps. Always use black background for the specular map, as no specular is needed for the background or the void. Keep the normal map background at its default blue color. Give the selected maps proper names. Press Render to bake the list. The renderer is currently configured to show the complete map only. However, as you might notice, there is no specular on the texture. How do we tell? Because there is no shiny metal look on the baked complete map. Do not get confused between specular and reflection, as they share some physical properties and both depend upon how reflective the surface is. In the current scene, we do not have any environmental elements to be reflected on the baked objects. Thus, what we hope to capture is the light reflection on the object or the specular map. To properly control or add specular, we need to change the specular level of the assigned material. Let's do another bake. The bake to texture will remember the last settings and the selected maps. Keep in mind, not all studios prefer to use the complete map, especially when combined with normal map. Instead, they use the diffuse map or the complete map without specular. And by doing so, they may avoid having texture issues, as we shall demonstrate next. Also, not all rims require baking the normal map. In fact, using the normal map, in certain cases, might cause some rendering issues. We cannot estimate what will be the best combination in order to use. We need to put those choices into tests before releasing the project. Inside Photoshop, or any image editing software, correct any deformation in the baked maps. I did not record all the image editing process. However, I will show you some key points of that edit. Use the alpha channel to select the whole baked map. By doing so, you can correct any age deformation. Use the rim template as guide during the edit. When creating textures for video games, you need to avoid using dark black, unless you want to mask places that should not have any specular or reflection. Repeat the same process for the normal map. Remove any color mismatch on the map to avoid having seams over the 3D model. Export all maps with proper size to the project folder. The recommended size is 512 pixel for complete, diffuse, and normal map, and 256 pixel for the specular map. Back to 3ds Max, open the materials list. Select the baked material from the list. You can also select the baked material by using Pick Material from Object. After the baking process, 3ds Max will create a shell node for both the original object color and the baked material. Remove the shell node and the original material. Then reassign the baked material to the rim and its components. Now, let's perform the final unwrapping process to adjust the UV map. The seam, which we have here, is due to the use of the complete map. To fix that, we need to neutralize the gradient mismatch over the intersected edges. I will do this fix off camera. This is the result after correcting the texture. We almost complete texturing the first level of detail. Let's adjust the mounting holes. Select the inside holes borders. Use the scale tool with local as reference to adjust the scale of the selected borders. Assign the baked material to other parts, such as the bolts limit or background. As for the bolts, we will texture them later, after baking the second level of detail maps. It's favorable to have one material for the rim and its parts. For other parts of the wheel, you can assign separate material for each one of them. Now, let's bake the second level of detail maps. This time, I will show you a different approach. Rather than using a low poly geometry, similar to the high-resolution rim, I will use a plane to bake the required maps. The plane scale should be slightly larger than the rim. When creating the plane by the keyboard entry, it will be created at the world center. Move the created plane towards the Omni light on the x-axis in the top viewport until it covers the rim. Your scene should look like this. Fortunately, the real-life laws of physics are not applied here. The rim will be visible even with an obstruction blocking the light source. Since we unchecked the real map size from the creation panel of the plane, its UV map is normalized to the map dimensions. And that's exactly what we want. Add projection modifier to the plane object level. Pick the high-resolution rim and bolts from the default layer. Press 0 on your keyboard to open the Bake to Texture utility. Now, it's a straightforward baking process. I am going to bake the complete, the normal, and the specular maps, each with larger size than we intend to use. The baked map has cropped edges. To fix that, we need to increase the scale of the plane a little bit. Then redo the baking process. When collapsing, the projection modifier, all the related changes we have made, will be stored to the object level. Thus, when adding a new projection modifier, we can easily retrieve those changes. Inside the material editor, delete the shell node and the original color material from the baked shader. Then, assign the baked material to the L1 rim and its components. Now, let's properly unwrap these objects. As you might notice, I have added black and gray switcher to the texture. I use this to fake shadows or darkening the surface of some areas. These rectangles should not have any environmental effects. So, we need to mask their locations over other maps as well. One more thing before we move forward. We need to change the ambient color of the material. The ambient default color is always similar to the diffuse color. For the alloy metal look of the rim and its components, change the ambient color to gray. assign the L1 material to L2 and L3 objects. Unwrap the objects properly to the assigned map. For the L4 and L5, they will be far away from the first camera or the player perspective. We do not need higher resolution textures for these low levels, though we could use the L1 material for the L4. We definitely need a new material for the L5. First, let's adjust the L5 rim geometry. The L5 rim will be combined with the tire, and they will be attached to the chassis to form a static object with no animation, only to fake the wheel's locations in the last level of detail. Combining both the rim and the tire in one single texture is a great choice for optimization purposes. You can also create and use a single texture for the whole L5 components. However, we are not going to uncover that in this tutorial. This cylinder will represent the tire, though we can scale up the rim's geometry to cover the suggested thickness of the tire. I prefer to avoid the usage of the scale tool, as we have discussed at the beginning of this course. After optimizing the L5 wheel's geometry, it is recommended to keep the flat edge of the wheel directed towards the bottom. In order to answer the question that we have asked in the introduction of this course, I have created this cylinder to represent the L0 tire. If we take a closer look at the separation area between the rim and the tire, you will notice a gap in between the two parts where it should not exist. My calculations to compensate the loss of the rim diameter, unfortunately, was not correct. And no calculations shall be. There will be always a gap in between the two parts. Thus, I do not recommend increasing the rim's diameter to compensate any loss. After using the tessellation by the Turbo Smooth modifier, as a bonus, I will show you the tire designing and texturing process, and how to close the gap between the tire and the rim. In order to close the gap between the rim and the tire, right-click on the Snap tool, then enable the Axis Constrain. Both the rim and the tire have the exact width. Thus, when moving two opposite vertices on the inside edge loops of the tire, they should snap perfectly on the rim at both sides. For the Axis Constrain to work correctly, switch to either the left or the right viewport. Use the rectangle selection during the selection of the vertices at both sides of the tire. Make sure that Ignore Backfacing is disabled. Finally, I am going to use this rendered image as texture for the L5 wheel. And that conclude our objectives from this course.